For section 5.4, we are coming to the end and we are doing the product to sum formulas or the sum to product formulas. Okay, so they're in the last part of your sheet. And at that point, once we go through this section, you will have gone through everything in this packet that I've given you. The one thing that's going to catch you off guard on this section is the even and odd properties. So remember, ignore this stuff. Remember, if you have the sign of a negative value, you can take that out and make it the sign of a positive. It's kind of like you're factoring it out, but you're really not. Okay, it's the property of an odd function. And then if you have an even function, basically if this is negative, you can ignore it. Okay, and that's what that means. So the odd function comes from the fact, I'm just going to use x to the third. If I shove in a positive, I get a positive. If I shove in a negative, I'll get the same value, but it's negative. Okay, so basically it's saying that if this is negative, the whole thing goes negative. For an even function, think about a parabola. And we did this forever ago, sorry. If I shove in an x, it'll give me a positive y. If I shove in a negative x, it'll still give me a positive y. So that's why you can just kind of ignore it. Okay, so just make sure if you generate negative arguments throughout this section that you resolve them using the even and odd properties. All right, so that being said, we have in 5.4, how many of these am I doing for you? We are doing like 8, and then you can do the rest. All right, so we have express the given product as a sum or a difference. So looking here, I'm given a product. I notice that I have a sine times a sine. You can't see. A sine times a sine. So I've got sine alpha, sine beta. Okay. So sine alpha, sine beta, I am going to turn around and change it into this format right here. And again, some of this stuff looks like, why on God's green earth do I have to do this? But this is prepping you for Cal 2. When you go in and you have to do all the calculus in Trig World. So, and plus they're just handy to know. So my alpha in this case is a 5x and my beta is a 2x. So I'm going to fix that by doing 1/2 of the cosine of alpha minus beta. So I've got 5x's minus 2x's is 3x's. And then minus the cosine of alpha plus beta. So alpha is 5x, beta is 2x, so 5x's and 2x's gives me 7x's. And that is all you have to do. So you're probably thinking, why again do I have to do this? Because this is equivalent to this answer. These two things would give you the equivalent answers. So let's go again. We've got a sine alpha, cosine beta. So I'm given the product. So here is sine alpha, cosine beta. So my alpha is 4x and my beta is 2x. And I'm going to change this into 1/2 of the sine of alpha plus beta. So 4x's and 2x's is 6x's. Plus the sine of alpha minus beta. Okay, so 4x's minus 2x's is 2x's. And then you're done. So, express the given product. So I have cosine and sine. So here's cosine, cosine, here's sine, sine, here's sine, cosine. Well, we're going to flip the order. Okay, so this one has sine first. So I'm going to rewrite this as the sine of x over 2 times the cosine of 11x over 2. And now I know what my alpha and my beta are. So here's alpha, here's beta. So I set this up as a 1/2 times the sine of alpha plus beta. So 1x's out of 2 plus 11x's out of 2 is 12x's out of 2, which is 6x, plus the sine of alpha minus beta. So alpha is a 1/2 of an x minus 11/2 of an x is a negative 10 halves of an x, which is negative 5x. So I have a negative 5x here, and now you should immediately note your argument's negative. You've got to fix that. Sine is odd. So I'm going to take this negative, and I'm just going to relocate it out front. Okay, so this now becomes sine 6x minus the sine of positive 5x. Okay. And then we want to go and start doing stuff backwards. So I have the sine of alpha plus the sine of beta. So sine alpha plus sine beta, and I can rewrite it using this. So if this is my alpha and this is my beta, then I have 2 times the sine of alpha plus beta over 2. So 2x's and 6x's is 8x's over 2 is 4x's times the cosine of alpha minus beta over 2. So 2x's minus 6x's is negative 4x's over 2 is a negative 2x. Okay, and remember, there's your negative argument. Cosine is even, so you can just ignore that negative, because regardless of whether you evaluate it at a positive angle measure or a negative angle measure, it's going to result in the same ratio. So just ignore that positive right there. All right, which means you can do this one, you can do this one. Let's find some interesting ones. You can do those. All right, so we want to verify the identity. All right, so it says start with the numerator on the left side and apply the appropriate formula of sum to product. So I've got the sine of 5x minus the sine of 3x. So here's the sine minus the sine. So I have sine alpha minus sine beta. So that is going to turn into 2 sine of alpha minus beta. So 2 sine of alpha minus beta gives me 2x. And then cosine of alpha plus beta. So, oh, I forgot the over 2. Hang on. Hang on. Did I just do that right? There we go. All right. So 5x's minus 3x's is 2x's over 2 is 1x. Sorry. And then cosine is going to be alpha plus. So that gives me 8x's over 2 is 4x's. Okay. Then it says apply the thing to the denominator. So I'm looking for cosine alpha minus cosine beta. So my alpha is 5x, my beta is 3x. So I have a negative 2 sine of, this says alpha plus beta. So that gives me 5x's and 3x's is 8x's over 2 is 4x's. And then I have sine of alpha minus beta. So 5x's minus 3x's is 2x's. Divided by 2 is 1x. Okay, and now how can I rewrite that thing? Well, this sine of x and this sine of x will reduce to 1. And then I've got a 2 over a negative 2 is negative. Cosine over sine with the same argument is cotangent. So I have negative cotangent of 4x. Okay, so that's an idea of how to do that one, which means you can do this one, and you can do this one. So that was pretty much the easiest section. And so the hard part of all this is when we wrap it all up in 5.5 and start solving equations. So that's where we're going now.